Hello, guys. Very good morning.
Hi, good morning, Sonali.
Good morning, dear.
Hello.
Okay, so you guys remember what we did last? Okay, I suppose I have to start from XINETD now. Was anybody can tell me where we left last? Okay, so this was done till trace root. Telnet was also done. We need to start from XINETD, I suppose. Okay. Just wait for a minute so that so less network coming. Just wait for a minute. Okay. So what do you mean by XINETD? Okay, so XINETD is the extended internet daemon, okay, which is an open source daemon which runs on many Linux and Unix system and manages internet-based connectivity. Okay, it is a kind of daemon which manages internet-based connectivity. Okay, is my voice audible to all? It offers
Yes,
a
I'm
more
audible.
version of INETD, the internet daemon. We have an internet daemon. Okay, so more secure version is XINETD. Okay, it performs the same function as INETD. Okay, it starts program that provide internet services. Okay, instead of having such servers started at system initialization time and be dormant until a connection request arrives, XINETD is the only daemon process started and listen to all the service ports for the service listed in its configuration file. When a request comes in, XINTD starts that appropriate server. Okay, suppose any request comes in, XINTD will start the appropriate server. Okay, so because of the way it operates, XINTD is also referred to as super server. So following are the important configuration files for XINTD. Okay, so in etc xinetd.conf, okay, this is the global xinetd configuration file. Okay, then etc xinetd directory. The directory contain all the service specific files such as FTP. Okay, so the task is to stop or restart xinetd. Okay, to start xinetd service. Okay, if I have to start the xinetd service, this is how to start the service, okay, and this is how to stop the service. In etc init.d there's xinetd start. Okay, okay, so this is verify that xinetd is running or not. Okay, so here it is seeing the status of that particular service. Okay, so this service belongs to etc init.d directory. Okay, so we need to give the path in order to start the xinetd and check the status whether the service is running or not. This is the configuration file of xinetd which contains this data: instances, log type, log on success, log on failure, CPS. Where these things means, so what does this mean? Okay, so instances mean that 60 time request. Okay, 60 requests can be sent, can be handled by xinetd at one time. Okay, at one time 60 requests can be handled by him. Then is there is log type. Okay, that where the logs will be made. Okay, the service log output is sent. Okay, then log on success. Okay, if the connection is successful, obviously the logs will be made or not. Okay, so whatever it is, the force xiddd to log if the connection is successful. It will log host name and process id and where log secure file. Okay, so log file, if the connection is made, so entry will be made in the log file. Then log on failure also the same. cps CPS means 2530. What does this mean? It limits the rate of incoming connections. Okay. So whatever the incoming connections are there, it will limit the rate of incoming connections. So if the rate of incoming connection is higher than this, the service will be temporarily disabled. The second argument is the number of seconds to wait before re-enabling the service after it has been disabled. The default for this setting is 50 incoming connections and the interval is 10 seconds. This is good to avoid DOS attack against your service. Okay, so this is kind of type of number, okay, 2530, which limits the rate of incoming connections, okay. So what happens is that the first argument means 25 connections can be handled, okay, at one time, okay. If the rate is higher than this, okay, that the service will be temporarily disabled, okay. And the second is means the 30 is to wait before re-enabling the service after it has been disabled, okay. Now what is IP tables, okay? So what do you mean by IP tables? Anybody knows what is IP tables? Okay. Actually, the firewall, okay, which protects us in our systems to not open, not allowed opening such different websites which are not of any use or which can pose a harm to our system. Okay, so that firewall is IP table. Okay, so the utility firewall developed for Linux system is IP table. Okay, so all modern operating system come equipped with a firewall. Okay, a software application which regulates network traffic to a computer. Firewall creates a barrier between a trusted network and an untrusted network. Okay, so firewall it creates a barrier between both of them. Okay, so firewall works by defining rules which govern which traffic is allowed and which is blocked. So how IP tables work? Okay, network traffic is made up of packets. Okay, so the network traffic is made up of packets. Data is broken up into smaller pieces, sent over a network, then put back together. IP tables identifies the packet received and then uses a set of rules to decide what to do with them. Okay, so how do they work? Firstly, okay, so network traffic is made up of packets. We know. Okay, so data, whatever the data is coming, incoming data is broken into smaller pieces called packets. Okay, and which is sent in line across a network. Okay, and then it is put back together. IP table identifies the packets received and then uses a set of rules to decide what to do with them. These are the set of rules. Okay, tables, chains, rules, and targets. Okay, so tables, chains, rules, and targets. What does they mean? Okay, so tables tables are files that join similar actions. A table consists of several chains. Okay, chain. What do you mean by chain? It is a set of rules. Okay, where a packet is received, IP table finds the appropriate table. Okay, then runs it through the chain of rules until it finds a match. Then rule is a statement, okay, which can block that incoming network, okay, or can forward another type of network. Okay, the outcome where a packet is sent is called target. A target is a decision on what to do with a packet. Typically, this is to accept it, drop it, or reject it. Okay. Okay, so Linux firewall IP table has four default tables. Okay, so these are filter, NAT, mangle, raw. Okay, so let's see what are all of them one by one. Okay, suppose a data has come to us. Okay, so now the four default tables are there. First is filter, it is the most frequently used one. Okay, so filter is the most frequently used one. It acts as a bouncer, deciding who gets in and out in your network. Okay, it has the following default chains: input, output, and forward. So input is that the rules in this chain control the packet received by the server. Output, the this chain controls the packet for outbound traffic. And forward is the set of rules control the packet that are routed through the network. Okay, so input, output, and forward. Okay, so all of them are same. Okay, only a little bit set of rules are different for all of them. Otherwise, all of them are same. Okay, so NAT is this table contains NAT rules, okay, for routing packets to networks that cannot be accessed directly. Okay, so when the destination or source of the packet has to be altered, okay, the NAT table is used. Okay, it includes the following chains: pre-routing, output, and post-routing. Next is Mangle. Mangle also contains the same. The Mangle table adjusts the IP header property of packets. Okay, so the table has all the following chains: pre-routing, post-routing, input, output, forward. And the last is raw. Okay, so it is used to exempt packets from correction tracking. Okay, it does not allow the packets from correction tracking. Okay, two chains: pre-routing and output. Okay, so you can see this diagram that a table has um, four destinations that from how the data has been sent. Okay, filters, NAT, mangle, and raw. And the last is target. Okay, a target is what happened after the packet matches a rule criteria. Non-terminating targets keep matching the packets against rules in a chain, even the packet matches a rule. So a target is what happens after the packet matches a rule criteria. Okay, so what happens when the rules, suppose the rules are taken, that all the rules are taken. Okay, so it what happens when a packet matches a rule criteria. Okay, so non-terminating targets keep matching the packets against a rule in a chain, even when the packet matches a rule. While terminating targets, okay, a packet is evaluated immediately and is not matched against another rule. Okay, so non-terminating targets, okay, they keep matching the packets, okay, because they're never stopping. Okay, so they keep matching the packets again and again whenever a packet matches a rule. Okay, while terminating targets will check a packet immediately. Okay, if it is not matched against another chains. So what if a terminating target has come? Okay, so what do they do with the packet? Firstly, they accept it. Okay, firstly they will accept the packet through the firewall, that yes, the things are okay. Okay, so they will accept the packet after the firewall. Then the the dropped package is not matched against any other. Suppose it is dropped. Okay, so it will not be matched against any other further chains. When Linux tables drop an incoming connection to your server, the person trying to connect does not receive any error. It appears as if they are trying to connect to a non-existing machine. Return. This rule sends the packet back to the originating chain so you can match it against other rules. Reject. Okay. So this firewall and sends an error to the correcting device. Next is send mail. Okay, actually, what happens is that when we have to send mail to the users, okay, so here we use the send mail option. Okay, so send mail operates as a server to both receive and send mail messages. Okay, we have mailx command as well. We have send mail command also. Okay, for sending mails and messages. Okay, but I can't show you the practical of send mail as because that is all abide. Okay, that is all properly bide things. Okay, we need to take the properties and rights for it. Okay, so sendmail listens for any mail messages received from other hosts and addressed to users on the network host it serves, and at the same time handle messages users are sending out to remote users, determining what host to send them to. So here is an example of sendmail command with an abbreviation. Okay, so this is an example of the send mail command which contains all the data which need to be sent. Okay, so here you can see available options. Okay, so send mail hyphen v hyphen f capital F sender ID I told you verbose hyphen f capital F sender Is my voice audible to all of you guys?
No, Sonali, there is a lot of network issue. Your screen's also, blanking out at sometimes.
Okay, is it visible now?
Yes, it's visible. For now, it's visible. Yes.
Okay. Okay, so hyphen V hyphen F capital F T I have told you. Okay, hyphen I, it is ignoring the dots on the line by themselves in a message body. Okay, and hyphen OEM, it is a kind of message format. Okay, so here you can see send mail hyphen V as I've told you, verbose hyphen F, hyphen F for the sender ID I told you, then hyphen F capital F, the sender name. Okay, then hyphen T hyphen I hyphen OEM, the recipient. Okay, and means to whom do I want to send, like this. And this is my message.txt file, okay, which contains all the data which need to be sent. Okay, so this will be read and that will be sent to the user itself. This is the other send will command block. Similar is the work of mailx command as well. Okay, was this document completed, guys? I explained DNS, I suppose FTP was left in here, no? Okay, rest was understood. Okay, FTP, I'll do it tomorrow. Okay, so guys, only small part is left, which I'll explain tomorrow. Okay, and tomorrow the class will end. Okay, so whatever your queries are there, okay, you can ask me today or tomorrow. Is it clear to you all, guys?
Yes, ma'am, clear.
Okay, any queries, Viraj? Anything which you're not getting? Any problem?
No, ma'am, no,
FTP
ma'am.
practical. Okay, for FTP practical, I'll be explaining tomorrow. Okay,
Okay,
and
ma'am, okay.
rest tomorrow. Yes. So tomorrow would be the last class of the session. Okay. Thank you so much, guys.
Thank you, ma'am.
Okay, dear. Bye bye.
Thank you, Sonali.
Okay, dear. Bye.